Time, one of the world's greatest treasures. It's something we have an abundance of, but can never seem to get enough of.
Now what if I told you about a way to get some of it back, or at least slow it down? Special relativity, folks. It's a very special theory relative to physics. All jokes aside, what is special relativity?
Special relativity is a theory developed by Albert Einstein in 1905, and it explains space and time and how time acts under certain circumstances. But just being called a theory is not actually what it is. It's much more than that, as people have done many experiments countless times to prove that special relativity and the phenomena that come along with it are true. First thing to note is that the theory of relativity is explained by two postulates, which are essentially rules or laws that help to prove the theory. Pretty simple, eh? So the first postulate explains that every inertial frame of reference, the laws of physics will be the same for everybody. So I could be doing this, or even this, and the laws of physics would always be the same. This is because in all the situations, velocity is relative, and I'm traveling in uniform motion, which means there's no possible way to determine that I am moving. Now let's say I do this, or this. Now it's not uniform motion because I'm changing the acceleration, so the laws of physics cannot apply and special relativity cannot happen. Now we wonder, why does this happen? So why could I be sitting in a plane going 800 kilometers per hour, or sitting down which goes 0 kilometers per hour, but all the laws of physics are the same? Well, that's because velocity is relative, which means you cannot tell you're moving unless you are referring to something else. Right now, I'm not moving relative to the ground. But if you say that the Earth is moving relative to its axis, then that applies. So the second postulate states that in all inertial frames of reference, the speed of light in a vacuum is always constant, which means that I could be sitting, walking, running, even driving, and the speed of light would always be the same no matter what I was doing. So now that we've proven both the postulates of special relativity, I would like to divert your attention to one of the greatest phenomena in the world: time dilation. Dilate, to make it become wider, larger, or more open. I'm sure you can guess what time dilation is about by now, but if you can't, I'll tell you. It's about expanding time. So for every frame of inertial reference, each person in their respective frame will measure time to be ticking at the same rate. Now let's say your frame of reference is the Earth. You will be measuring a clock to tick at one rate, and then if you look at another person's frame of reference, such as in a plane traveling around the Earth, you'll notice that their clock ticks at a very different rate when comparing your frame to their frame. What? How could one clock tick at one rate and another clock tick at a different rate? It's actually pretty simple, because as we stated before, velocity is all relative, and you can only tell you're moving relative to something else. So how does this apply to our clocks? When you look at your clock, you see that your clock is this far away from you, but when you look at your friend's clock, you see that it's that far away from you. So we got all of that. But what does it all mean? This means that light has to travel longer time to reach greater distances, and therefore, your friend's clock looks like it's ticking slower because he's further away. Interesting, but bear with me as it only gets stranger. Now let's say you circled around Earth for 30 years at light speed while your friend stayed stationary. After returning from your 30-year trip, you would have only aged about 5 years, while your friends would have aged much, much more. In essence, you would have traveled about 30 years into the future. But if all time dilation is based off of relative velocity, wouldn't the process of aging not occur? Well, thanks to quantum biology, we know that bodily processes such as aging and growing happen on a level where photons and electrons are exchanged. This is because photons, which travel at the speed of light, only have to move such a short distance within your body, and chemical processes happen in a shorter amount of time. Now you're traveling at the speed of light. Because you're going the same speed as the photons, they have to travel a much longer distance, thus taking more time to reach their destination and making bodily processes occur more slowly. Do you know how crazy this is? With this kind of power, we could travel into the future and see robots and flying cars. Or could we? Unfortunately, there are two problems with this. First, no human would be able to travel at the speed of light and live to tell the tale. Secondly, it's not really time travel as time is still moving, but only slower for you, which means that there's no way to travel from the future to the present, past, or even from the present to the past. Even though this is the case, there's hope that maybe one day we will be able to travel into the future and turn our dreams into reality.
Hi there. This video was made for the Breakthrough Junior Challenge. I hope it was enjoyable and entertaining, and thanks for watching.